Hello friends, welcome to C# Intermediate to Advanced tutorial. Now you are watching part 3 of the sub-series thread synchronization. So in the last 2 videos we learned about the critical section monitor. Also we talked about the problem in generating the sequence number and what happens when multiple threads access the same variable. So in the last video we talked about the problem of generating the generating the sequence number and what is the need for synchronization, and in this video we will make this current count as thread safe. So this time we will create a class called counterMon. So in the last video also you can try the same, but here we created a class called counterMon, and the counter monitor contains a sequence generator. So here we have a integer variable to track the sequence counter, and in the constructor we are initializing it to 0. Next, here is the generate critical section based task. Here we are handling this, and if you see txt number, as we already did, we are parsing it and storing that as a sequence max, doing the same thread sleep. This time we are creating counterMon instance of this class. Then we are creating a parameterized thread start. This time it will point to a different task B. That means task A, a second version of task A, we can say task B. And here we will start 4 thread like we did previously on generate click. We created 4 thread. The same way here we are creating 4 thread instances. Then we set name this time. Why? Because we want to pass this as a parameter, or you can have one more member here that will have a string member to hold the thread name. Anyhow, since we have a name property in the thread itself, we are using that. We are setting name for each thread as A, B, C, D. So now we no need to pass any parameter because the thread itself holds the name. Then we are starting all 4 thread, and if you see we are passing the counter object as a parameter. So now all 4 thread using the same instance, and let's state this counter obj as A. The object A is accessed by all 4 thread. Right, because here we are passing the instance A for all thread. Now let's look at task B. Task B is receiving an object parameter, and we are naming that as a counter. So this is the old comment. So we are typecasting this counter as counterMon. So here is the counterMon, right? So we are passing parameter to the thread, and we are passing that, and we are having the counter as a counter1. But if you see thread T1, T2, T3 and T4 all will execute the same task, and when they parse the input, they all have same reference. That means T1, T2, T3, T4 all share the same object in the heap. Here we use new keyword, right? So all 4 threads use the same object, and here we retrieve the thread name. Here we assigned the name, right? So what we are doing here is a thread dot current thread. Current thread will give the instance of the thread, because this is threaded function, right? Some thread is executing this, and we want to know which thread is executing it. So that's why we use the property current thread dot name. Whatever name you assigned, that will be retrieved here, and we store that as ID. Then loop end, we are using the sequence max, as we already did in our generate method. Same way we are forming the loop end. Here we are forming the loop based on the loop end. Now this time, if you see, before performing the calculation, we are using the Monitor.Enter, and after performing the calculation, we are doing Monitor.Exit. And if you see what object we are synchronizing, the object that synchronized here is a counter 1. Counter 1 we are passing to the Monitor.Enter, and here we are passing the same counter 1 instance. That means here lock will be occurred, and here the lock will be released. Even though multiple thread T1, T2, T3, T4 is entering and exiting this, when T1 is inside, let's state this is the critical section. When T1 is using the counter 1, T2 will not use it. So it cannot occur lock on counter 1. So it will wait here. Once T1 exceeds, T2 will enter. This way, if you see, the sequence number generation won't fall under the error of read-write context switch. So once T1 enters, it reads the content of SEQ counter. This time we are using the internal member. From counter 1 object, we are reading the sequence counter, we are incrementing it, then we are printing it, and after that we are releasing the lock. So instead of saying V, here we can say T1 occurs the lock. It makes use of the synchronized object counter 1. It performs the sequence increment, it prints the sequence number, then it releases. Then if T2, T3 are waiting, only one is allowed to enter. So it will be a race condition. Even if 3 threads are waiting, only one can enter. Suppose if T3 is allowed to enter, T2 and T4 will still wait, and T1 will come back and join this waiting queue. So we cannot guarantee the same order the thread will enter and exit. Same order in the sense T1, T2, T3, T4, T1, T2, T3, T4. So it won't go like that. In any order they can enter, but only one thread can occur the lock. Thereby only one thread can use the shared instance counter object. So counter object is in the calling context. Inside the thread context, if you see, the object is counter 1, but both will point to the same instance in the heap. So this time when we run the exe, it will generate the correct sequence number. So we will experiment now. Let's go to the demo. Now we will click on this generate critical section. Generate sequence number using critical section, or using the critical section based thread synchronization. Okay, first we need to generate the class instance. So I'm right clicking the project, add class. We will name this class as countermon. Countermon will have an internal member, and we initialize that in the constructor. Let's keep a comment. Now we can go back to our start sequence generation. The code was already explained in the slide. So we parse the sequence max, we create our countermon instance, then we create a 4 parameterized thread. We set thread name, then we start our thread by passing the same instance of current obj, counter obj. So for all 4 threads we are passing the same object, and that means T1, T2, T3, T4 will access the same object. So task A we already defined, and task A is not thread safe. Here it uses the internal member current count, and if you need you can use this same notation also. Now if you see, we use task B, and in this, wherever we access the counter1 instance, that's where we are marking it as a critical section. So only these two we want to synchronize. So only these two highlighted statement we want to synchronize. That's why we sandwiched this between Monitor.Enter and Monitor.Exit. Now we will save this and test it. We will go with the 50 first. And you can see the sequence ended at 200, and if you examine the output you won't see any repeatability also. You can check randomly at any different interval, 65, 66, 67, 68. But if you see, the thread sequence may not be same. Say for example, at this location A, C, B, D. Here if you see A, C, D, B, right? The sequence may change, A, C, B, D this time. Alright. Now we will test this once again with a different sequence number. This time I'm raising it to 100. That means 100 into 4, it should end with the 400. And you can see it ended with 400. And some thread already quit. So B. So that means it ran 100 times. Since it finished its duty, that means it ran the loop for 100 times and it exited. After B exited, A is still printing, C is still printing, and here you will be seeing BD A4 has exited. and the other 3 thread exited here, whatever. But the gist here is now we are getting the correct sequence number generation. So the sequence number ends with 400. So here this test is not to generate the sequence number. Here the test is to see how synchronization is performed by the threads. Now since our counter obj is inside the critical section, it's working perfectly. So as a quick experiment, let's comment these 2 lines. Now there is no critical section here. Let me generate 25 times, which is such a low number, but that's okay. If it doesn't work and if we see 100, then we will raise the number, but most probably we will see the issue. See, 88. And if you put back this critical section, you will see 100. See. Alright, that's all here in this video. Thank you for watching. Bye.